Okay, so we are now looking at PET, which is also called the project evaluation and review technique. So under the PET, we have project evaluation and review technique is what it means by this PET. So P is standing for the project. Then the other one, so we are looking at the project management. How can manage a project? So a project, then E is for evaluation. So evaluate that project. And then after we evaluate that project, we go into the aspect of R, which is for review. And then the other component, the T is standing for technique. So this is about what we look at. Now, in this PET, first and foremost, we have to look at the composition. The composition that should be here are, number one, we need to find the expected project duration. So we have expected project duration. Then the other one that we need to look at here, now this expected project duration is denoted by a symbol where we say our mu is equal to, or we stand for, I'll give you a breakdown there, then 4 ml plus P, then over 6. The O is equal to optimistic time. So this time we have time which is optimistic. Then we have the ML is most likely. So this is most likely. And then we have the P is pessimistic time. So this is a breakdown of how we find that. Then the 4 and 6, these are constant values. They are just part of the formula. All right, now we also get it down to finding the project variance for each activity. So we have the project variance. So on this project variance is given by the variance of the project is equal to O minus P over 6. Then we square. So this one we are simply saying where our O is the same optimistic time. So this is optimistic. Then we have the P is pessimistic. And then the 6 is part of the whatever it is that we have here. So the 6 is a constant. Now, network diagram depends. Here we now come up with the drawing now, network diagram. Okay, so we need to go into drawing project network. Which is on the network diagram. So here with this one, we use the precedence diagram. So we get down to the precedence. Precedence information. So the information that is there given in the question is what we need to use as we get down to this one. Now, and then of course we have to look at the other one here on the critical path in the project. We look at the critical path. Now this critical path is always the longest path. So this critical path is the longest path. It gives the idea on how, if you are constructing a house, how long it will take. So this one indicates the time taken to complete project. So time taken to complete a project. So this is on the critical path. So how long are we taking to complete the project is on the aspect of the critical path. All right, so now from here, we need to get down to the information that is actually given. Okay, we can get to a question so that we see the one that we are going to do. Okay, so we can have this question here where we have the information here. The following table shows the various activities on the development of a new product in your organization. And then we have the aspect where we now have to find, we've been given the information that we have here. So activities, we have activity 1 through to activity.
Excuse me, sir, you have not beamed the question.
Well, the question is not there. You are going to see.
Okay.
You have to see the question?
No, you have not shared yet.
Is it okay?
Now it's okay. It's okay now.
Okay, all right. So the question is here. Now they're saying the following table shows the various activities of a development of a new product in your organization. So we have the activities that are done, activity 1 through to activity 10. So we have the event A, B, C through to G. Then we have the immediate predecessor there. Then, of course, we have the activities that were done before the other one. So meaning that immediate predecessor simply means the activity that was done before the other activity. A predecessor is somebody that was there before you got a job. All right, then like on activity A, there's a dash, means that there was no activity that was done before A. Then after A, there was B, and then after A, there was C. Then after B, there was D, and after B again, there was E. Then after C, there was F. Then after D, there was G. Then after O, E, F, and G, they were done at the same time. There was H. Then after activity H was done, there was activity I that came. Then after I, there was J. Now, the first and foremost, before we get into drawing of the network diagram, we need first of all to calculate the missing points, the missing values in the data points. So for activity A, we can find activity throughout activity going down to, so now getting down to activity A, they have given us the optimistic time and then most likely time, the pessimistic time. They need to find the missing values, these points, what was missing in each of these ones. Okay, so meaning that for activity A, we need to start finding. So for A, we can say we have activity A, we are finding the time expected. The formula to use is equal to optimistic plus 4 on most likely, then plus pessimistic, then over 6. That's the formula. So meaning that for A, we need to check what has been given there. So for A, we have the optimistic is what? So optimistic there is 2, then most likely is 3, and then the pessimistic is 4. All right, so meaning that these we can substitute them. You can substitute them and get the value in this given question. So for each of these, for B has been given already, they're calculated. These ones are already okay. These ones are already okay because the time expected is the same as the mu. Looking at the formula which I gave out, the formula which is this one, the other one here, which is the expected time. Okay, so we have, this is the formula to use. This one is the same one as mu or time expected. So mu or time expected is what we have by that. Okay, so for A, we can calculate. So we have optimistic is 2. So we can find optimistic is 2. Then plus 4 is constant. Most likely is a 3 from the question. And then pessimistic is 4. Then the 6 is constant. So you can find the value for that. So meaning that it will be 12 plus, that will be 18 over 6, which will give us a 3. So A is a 3 that we have. All right, so now we can find for B, B has already been calculated. The TE for B is already there. Okay, so TE for B is 2. These other ones from B throughout to G is already there. This is what is just the most important. And then we can finish finding the expected time expected for H. Let's finish up this column first. Time expected. These other ones we can also fill in depending on that formula. So you just really need to make the subject of the formula to sort out the missing parts using that formula, which is standard. So for H, the time expected, we have the optimistic is a 3. So optimistic is a 3. Then most likely is 4. Then we have optimistic 3, most likely is 4. Pessimistic is 6. So we can substitute here for this is for H. These other ones were given. So here we have already found for the first one is the 3. We have found the 3. So we can now find for H. So for H, using the same formula. So for H, we are going to say our H, our time expected for B was already given. Okay, so B was already given here. B was 2.2, or it was a 2 there for B. B was a 2. Now we are going for H, which was not given. So optimistic plus 4 is constant on the most likely, then plus the pessimistic, then over 6. So meaning that optimistic is a 3 plus 4 on most likely is 4, then plus the pessimistic, which is 6, then over 6 here. So for our H, is actually going to give us, that is 16 plus 12, which is giving us 28. So this is the 4 by 4 is 16, so to give us 28 over 6. It is actually giving us 4.67, 4.67, or simply 4.7. So this is only the aspect of finding the H. Then after that, we need to now sort out the other one. We need to check now, find the time expected. So here for H is 4.7. Then we can get down to finding for J. For J, we have optimistic is 1, most likely is a 3. Okay, so we have the optimistic is 2, most likely is 1, pessimistic is 3. So this is only how we get to find the time expected for J. So for J, we are going to say our time expected is actually going to be, we have optimistic plus most likely, then plus the pessimistic, then over 6. So our time expected is actually going to be 2 plus 4 on 1, then plus 3 over 6, or 6 is constant. So here on top you are getting, it's just a 9 over 6, which is giving us 1.5. So this is it, what we have looking at this one. So after getting the 1.5 here, we need now to, so we have finished up this column, which is very important that we need to use as we are drawing the network diagram. So here I say calculate all the missing data points. So meaning the other points that we need to calculate for B, what we need to calculate is the pessimistic. On this one, we need to calculate that. This one, we need to calculate that value now. This one, so we have to manipulate the whatever we have been given to get those values. So here we need to calculate this one. All right. So if you want to go to for B to find the pessimistic, what we need to look at the breakdown of what has been given, so that we need to find the missing figures. So the time expected for B is actually 2. Then we have optimistic time for B. It is 1. Most likely it is 2. So most likely is 2. So we can substitute there and get whatever it is we need to get. All right, so now as we go to B, so on B, we can say for B, what we have been given is time expected is given by the formula O plus 4 most likely, then plus the pessimistic over 6. Now, this one has already been sorted out. For B, it is 2, which is equal to optimistic time is 1 plus 4 on most likely. Most likely was given. The TE was given, time expected was 2. Then most likely time was actually 2. So we can substitute here, and then the pessimistic was X. So it's just about using this formula to make the subject of the formula, and then we get whatever we need. So one example for that one. So we need to now cross multiply. That one will be 2 is equal to 6 plus 1 is actually 7. So it's 7 plus X, then over 6. So we are just sorting out. So over 1, so we can cross multiply. It will be 2 on 6, which is equal to 7 plus X. So meaning it will, from here, we will build up. It will be equal to 12 is equal to 7 plus X. So the 12 minus 7 is equal to X. So meaning our 5 is equal to X. So this 5 is what missing figure that we have found, which is for the pessimistic is equal to 5. This is only what we need. So the other activities, we need to also sort them out with the other missing parts, depending on the information given in the question using the formula. But what is just very, very important is to get the time expected. These other ones can be found for each of them using the formula as we manipulate the formula to get these missing figures using the time expected equal to O plus 4 is constant for ML, then plus P, then over 6. So we are using this one as a constant value of formula to find the missing parts. So by just substituting and cross multiplying, we are able to get the other figure. So, but we are interested in this one. So the missing figure for the first point is calculated using that one. All right, then we get into drawing the network diagram now, because this is what is very, very important. Okay, so drawing the network diagram, we need to get the information here. So what is going to happen is we need to check on how this one will be, because for this one, we are using this information. Activity A was a starting activity. So activity A was a starting activity. And then after A, there was B. So you can say our A, so here we can say activity A was a starting activity. So A started. So after A, so this is the on activity A. So after this activity A, that's when B, okay, that's when B, activity B came in. So there's B that came in. And after A as well, there was the actually C. So there's A and there's a C here. Okay, so this is what we have. Then after B, there are two things that came in. Okay, so after B, we had the D and E. So from here, there was a D that came in. So for after B, there is a D that came after you completed that project or that activity. And then there was actually E. So there's E at this point. So that is, this one is E, activity E. Okay, just repeat a little bit. So there's E on this one after A. All right, now, so after B, there's D and E. Then we're getting down, after C, there is F. So after C here, after C has been completed, there is our F coming. So this is our F. And then, okay, so this is about how the network diagram is developed. So we now, after C, there is F. Then after D, there is G. After D, there is actually G. So there is a G that has come in after D. Then from here now, we can see to read that after all these three activities complete, E, F, G, E, F, and G, after all of them complete, we are going to have an activity, okay, which is activity H. This is what is going on. So H has come in after all these three complete. All right, now, then after they complete, then H, after H has completed, there is a J. So there is a J here after H has completed. Then after J, so H, there is a J. Okay. All right, so now here, after J was supposed to be actually here. After J, there was, so after H, there is I. Okay, so after H, there is I.
I.
Yes, correct. So there is I after. Thanks for that. So there's I here. After, so this was correct. After H, there was I. Then after I, there was J is the last activity on this project. So J is the last activity. So this is when you're constructing a project, you consider these activities, which one was starting first, because when you're even building a house, you need to have a foundation first. Then the other things should be following. So there's activity before anything, before activity A, there was nothing. So A was a starting activity. That's what it means, because there was a dash there. Now, what we need to do, we need to put this expected duration for activities. So for A, there is a 3. B, there is a 2. We are using those TI. These are very, very important. Then for C, 2.2 here. So here is 2.2. And then for D, we have 5. Then for E, we have 4. Then for F, we have a 3. Then for FG, we have a 2.2. Then getting down to H, we have 4.7. Then I, we have a 4. And then J, we have 1.5. So this is about part B of this problem on drawing the Pert diagram. So this diagram comes in when you are actually looking at the precedence diagram, which activity, which or the project are you going to start with? So we have answered part B. Now, for part C, we can do it here side where we need to find all the various roots. So the end point is J, so we can move from A. There are 3 roots here, of course, A to B. So A to B, we can go to D, A to B to D to G, then to H.
I and J.
Correct, I and D and J. So from here now, you can aggregate, you can put this 3, then plus a 2, then plus a 5, then plus a 2.2, then plus 4.7, and then plus 4, then plus 1.5. So manually, we can compute that and get what answer we're getting. So we can add and get the answer here. So that's, okay, so that 2.2 plus 4.7 plus 4 plus 1.5. So it's giving us 22.4. 22.4 after adding that. Is that so? Okay, let's see, add again. It is a 5 plus 5 plus 2.2 plus 4.7 plus 4 plus 1.5. It's giving us 22. Okay, so 22.4. These ones, if they are in days, it's say for 22.4 days, but we have to go for the other one as well. So it's A, this time around, A getting to B, then getting to E, then getting to H, then getting to I, then getting to J. So it will be 3 plus 2, then plus 4, then plus 4.7, then plus 4, plus 1.5. So we can get the value there. So it's actually giving us 19.2 days. So we're just trying to find how long in the maximum possible duration we are going to have to finish working on these activities or this project. Then the other one will be A getting to what? To C, getting to F, then getting to H, then getting to I, then getting to J. So meaning that T, it will be 3 plus a 2.2. Okay, so 2.2 plus a 3 plus 4.7, then plus
4.
Yeah, plus 4 and plus 1.5 plus 1.5. So here you can find the value that we are getting. So here for this one, it will give us the value here where we are going to say 3 plus 2.2 plus 3 plus 4.7 plus 4 plus 1.5. So it's 18.4. So 18.4. So the critical activity here is this one. So this project can be completed to determine the critical path. Critical path is that answer there. So the critical path is the longest path. Okay, so a critical path, we are simply saying our critical activity or critical path is just that one, which is A to B to D to G to H to I and to J, which is actually giving us 22.4 days. So this is about what we are saying on this part C of the problem. So this network diagram, we just really need to understand on how to construct it, especially when looking at the expected project duration, which is given by the time expected on top there. So we can just manipulate this one to find expected times that we use on the project network diagram, and then we sort out. Now, on this one, we will just end on the network diagram, on the PET diagram. But of course, this PET diagram, it has also the limitations of PET. So the limitations of PET are a number. Of course, we'll mention the first limitation. There are limitations, of course, but we can also look at the advantages. So the limitations, it may be difficult to construct. Okay, so it may be difficult to obtain, difficult to construct. Then number 2 limitation is that it depends on project activities. Okay, so it depends on expected project time, okay, expected project duration. Okay, so you really need to know the duration for each activity, because even when you are building a house, those who are building, they need to know. You need to know how many days would it take for you to finish constructing a house. So it depends on project duration, which is the TE or the mu. So it depends on this. That is another limitation of PET. Then we have also of course, there are a number. Okay, so we need to know. So now we're looking at the advantages. Okay, so advantages of PET. With the first one, we just need to know that it gives us it shows how long the project will take. So it shows how long project will take. Okay, so this is on the first one. Okay, and of course, it also indicates the starting activity. It indicates starting activity. So you need to know which activity is starting before the other one can start. Okay, so this is it on this aspect of advantage of PET. Okay, so, and it is used for planning. It is used for planning, because you know which activities are starting. So you can plan on how you're going to use your resources wisely as you manage a project. And it will be also okay to manage your inventory. Maybe you can manage your cement properly, because you will know the duration of the project. So you have to manage your cement properly so that you don't run out of inventory. So this is about what this PET diagram is all about, on constructing it using the formula, that one. So what is just important is to make sure that you go through the material, and where there are issues, we'll be able to go through again, especially when looking at the different question in the next class, where we now look at the cost management as we look at this course. Unless there are any questions. So if there are no questions, we can end the class for now.
Sir, so this one where they are saying explain the limitations of cut. It simply means the pet.
No. This is a different subtopic altogether, which we are going to look at in the next class. I need to explain to you the Gantt chart.
Okay. So that will be in the next class.
Yes. So the first part of the class, we have just done this first part for the ones on top here is what we've done. This one, we haven't looked at this Gantt chart. This one will be covered in the next class.
Okay. Thank you very much. Meaning we have done A, B, and C.
Yes. For the sake of this class for today.
Correct.
All right, then, thanks.